All right, so here's our last example. We're asked to evaluate this indefinite integral. We're asked the derivative of what function is the green one I'm highlighting here. We're asked equivalently to go ahead and find the general antiderivative of the green function. Before I go ahead and do that though, I want to do some algebra cleanup on my green function. When I look at this green function, I see 5e to the x. I see a constant times a function of x. Then I see this subtraction sign right there. Great, that means I can compartmentalize my thinking and just think about the derivative of what function is 5e to the x and deal with this part separately. Now, this part has some algebra work that I would like to deal with. I have a numerator and a denominator. I can't compartmentalize my thinking here. I can't just say, well, what's an antiderivative for the numerator and what's an antiderivative for the denominator? Just like you can't differentiate across quotients, you can't undifferentiate across quotients. So because of that, I see here that I could do a little bit of algebra. And I could rewrite this portion of the function as with terms, meaning across addition or subtraction. So I want to do a little bit of scratch over here. And I'm going to say that x cubed minus 2x divided by x squared, well, that's equal to dd division by my denominator. I'm dividing by x squared. That means I'm dividing each term by x squared. We're so used to going in this direction, getting common denominators, and to simplify our fractions. We're not used to going the other way and decomposing that fraction. Yeah, but there is no side to equalities. That's the whole point. They're the same. X cubed divided by x squared is just x. And then we've got minus 2x divided by, minus 2x divided by x squared, which is just minus 2 over x. Taken one step further, this is x minus 2 times a 1 over x. All right. So, orange is orange. Orange is equal to x minus 2 times a 1 over x. And see if you can see the algebra mistake I have written right here. Orange is orange, right? That's what we did on our scratch. But what am I doing? Oh, I'm subtracting that whole thing. I need to go ahead and distribute that negative. So just doing a little bit of algebra to help myself undifferentiate easier, helping myself think backwards. So we've got minus an x minus a minus, okay, plus 2 times 1 over x. Now it's in a beautiful form for me to undifferentiate, for me to integrate. I've got a constant times a function of x minus a function of x plus a constant times a function of x. I can just think the derivative of what function is 5e to the x, and then minus the derivative of what function is x Just think about that on its own. And then 2 times 1 over x. I can think about the derivative of what function is 2 times 1 over x. And then again, that 5 e to the x is a 5. It's a constant multiple. I could even bring this out in front if I wanted to, right? Because I'm saying the antiderivative of a constant times a function is just a constant times the antiderivative of that function. I encourage you to pause the video right now and make sure you're comfortable with the algebra, and then think about why I'm choosing to write my green function this way, and then chime back in. Okay? So welcome back. I'm now just thinking about the derivative of what function is 5 times e to the x, and that is 5 times e to the x. The derivative of 5 times e to the x is 5 times e to the x. Then minus the derivative of what function is x. X is an x to the 1, if you will. Adding 1 to this exponent, that's x squared, dividing by the new exponent, 2. Is this true? The derivative of x squared divided by 2? Is it x? Convince yourself. And plus, now, the antiderivative of a constant times a function of x, that's going to be the constant 2 times the antiderivative of that function of x, and I'm going to make a mistake here. The derivative of what function is 1 over x? The derivative of ln x is 1 over x, right? Oh, moreover, the derivative of the natural log of the absolute value of x is 1 over x. Right? And what did I forget? My plus c. And here I am, and I am done. I wanted to just point out one other kind of common, I picked this problem, or I made this problem up actually very intentionally. This piece right here of having that x with writing that exponent as a 1 can be a little funny for people, but right here, if you looked back, like just the problem we did right before, I wanted to write this as x to a power so I could use power rule in reverse. Look what would happen just off to the side if I was just integrating 2 over x, finding the general antiderivative for 2 over x, right? Well, if I wrote that, hey, I want this as x to the minus 1 so I can do power rule in reverse, I got a constant multiple. Look what happens right here. Add 1 to the exponent. Oh, minus 1 plus 1 is 0. And divide by the new exponent. What is this? This is garbage, right? That's undefined. Right, so if you ever accidentally write 1 over x as x to the minus 1, thinking that you're going to want to do power rule in reverse, don't fret, you're going to catch your mistake right here. All right? And I'm going to leave, we've talked through this pretty thoroughly, but I'm going to leave a check to you. If I take the derivative of yellow plus orange, yellow plus a constant, do you in fact get this green function? You should. Thank you for watching.